Hi guys, wanted to give you a rundown of chapter 2.1 day 2 notes. So we're kind of finishing up things with functions. If you have a couple functions, so if you'll see here you've got f of x plus g of x. So we're talking about two different functions. You can do operations with functions. Okay, there's 5 different things you can do with functions. You can add them together, you can subtract them from each other, you can multiply, and you can divide. There's a 5th that we'll talk about on the 2nd page, but these are the main things that you can do with 2 functions. Now, these 2 functions, when you add them together, you're going to create a new function. So if I take f of x and g of x and add them together, I'm going to get a new function that's called f plus g of x. Okay, so that's what you're doing. You're creating a new function. Now, these functions that you create, well, they're functions, so they're going to have domain restrictions as well, possibly, okay, or at least domains that you've got to take a look at. So over here, that's what I'm saying over here. If you add 2 functions together or subtract or multiply or whatever, your new function is going to have the same domain as the other 2 put together. So for example, if I've got function f is all real numbers, okay, no fractions, no radicals, no nothing. It's all real numbers. But then function g has a domain restriction, so like x cannot equal 2. Well, this new function that you're going to make is going to put those 2 together. So it's also going to have the restriction of x cannot equal 2. It's always going to happen. So that happens with when you add, subtract, or multiply. When you divide, there's another thing you got to look out for. Okay, so take a look at this right here. If I'm dividing by function g, then that means that function g is in the denominator of a fraction. So I need to make sure, I need to go over to the side, since I've created a fraction, I need to make sure that my denominator does not equal 0. So if you're dividing, you're always going to have a denominator that you've got to be concerned with. Okay, so let me show you these examples down here, and that'll make a little bit more sense. Okay, so what I did was I gave you guys 2 functions, f of x and g of x. Now both of these have domains of all real numbers. There's no issues, no fractions, no radicals. And then I came down here and we did f plus g of x. So we added the 2 functions together. All we did was combine like terms. Okay, and that new function has a domain of all real numbers, which is what we think should happen. Then we did b. We subtracted the 2 functions. Now pay attention, when I subtract function g, I put parentheses because that function g is a binomial and I need to make sure that I distribute that negative when I do that. Okay, so there's me subtracting. And again, I get this new function, and the domain of this is also all real numbers. Now, if I go back to the first example, I skipped something. Okay, I found this new function, and then right underneath it, I said, find f plus g of 1. Well, what we've done is we've created a new function that's called f plus g. And so if I want to find f plus g of 1, I just need to take the number 1, put it into this new function, and simplify it. So this is f plus g of 1. So that's what that means. So you're going to see a couple examples like that in your homework, and I just wanted you to see it here. Okay, for c, we multiplied the 2. So they're both binomial, so I had to FOIL them out. I wrote my answer in descending order. I've got the x to the 5th, the x cubed, the 2x squared. If you flip the 2 middle ones and you didn't do it in descending order, it is not the end of the world. Okay, but again, that has a domain of all real numbers. But d doesn't. Okay, I created a fraction when I divided the 2 functions. So I need to go over to the side, I need to set my denominator not equal to 0, and then I need to figure out what x value would create a 0 if I were to put it in. Now this is kind of a weird one. It solves and you get x cannot equal, this should actually be the cube root, because this is a cube. So it's the cube root of negative 1/4. So that's the one restriction, is that x can't equal the cube root of negative 1/4. Okay? On the bottom, I gave you a couple functions that did have domain restrictions. So this is a fraction, x cannot equal negative 2. This is a fraction, x cannot equal positive 1. And so right away, I came down here to do example A, and before I even did it, I wrote the domain. I told everyone, I said, I will bet you the domain of this function is going to be x cannot equal -2 and 1, because that's the combined domain of the two original functions that we had. Okay, so then I multiplied the two. When you multiply fractions, you just go straight across. So I multiplied the two fractions, and I got this answer right here. And sure enough, if you put a -2 in for these two x's, you're going to get -2 squared, which is 4. Then you're going to get -2, so now you're down to 2, but then you're going to get -2 again, so there's a 0. So you're going to get a 0 in your denominator if you try to plug a -2 in. If you plug a 1 in, you're going to get 1 plus 1, but then -2. So you're going to get a 0 as well. Okay? For example, B, we were taking f divided by g. So I took a fraction divided by a fraction. To do that, you multiply by this fraction's reciprocal. So we flipped it, and then we multiplied straight across. Okay? Now, in doing that, first off, there's two automatic domain restrictions, the -2 and the 1. You can't put those in. It doesn't, if you look at this, it doesn't look like 1 would be an issue. If you put a 1 here and a 1 here, you're going to get 1 plus 2 is 3. No problem. However, if putting a 1 into this function at any point, so right here, 1 minus 1, will mess up your function, then you have to exclude it. So that's why -2 and 1 are automatic answers. But then also, if you look at this function we created, if you put a 0, so if you take x squared plus 2x and set it not equal to 0, you're going to get another domain restriction that we didn't even see. Okay, so that's 0. So those are the four main operations that you can do with functions. Then we turn the page and we find that there is a fifth operation that we can do, and it's called a composition or a composite function. It uses this symbol right here. This is read f of g. So this right here, we say f of g of x. So f of g of x. You can also write it this way. Right here it says, this is how the book says it, f composed with g. You will never hear me say that in class, okay? F of g of x. This is another way of writing it where you literally put function g inside of function f. So f of g of x. And this is a very literal way of what a composition is. So if you look at this, we're going to start and we're going to find g of x. So we're going to take some value, x, and we're going to put it into function g, and then we're going to simplify it. But then that answer is now sitting inside of f. So that answer is now going to get input into function f. We're going to do that math, and then it's going to spit out a final answer. So this little picture on the bottom, this is what I'm showing you. So here's some input. You put it into function g, you do the math. It comes out of function g as an answer, but then it goes straight into function f. You do that math, and then this is your final answer. This is the answer, not this. Okay, this is just kind of a in-between middle answer before you get to your final answer. All right, let me show you an example. These aren't that bad. They just probably sound weird. All right, so here's f of x, 4x plus 1, and g of x, 2x squared plus 3. So I've got two functions. And I want to find f of g of 1. Now, so the first thing, so this is the same as f of g of 1. So like if I put the g of 1 inside its own set of parentheses. So the first thing you're going to do is this. You're going to find g of 1. So this is the other way to write it, f of g of 1. So the first thing I found was g of 1. So I took the number 1, I put it into this function, and I got 1 squared times 2 plus 3 is 5. But then that 5 is now getting placed into function f. That's what this says. Plug it into here, and then whatever that answer is, it's going to get plugged into f. So I took a 5 and put it right here, and I got 21. And that was my answer, and I was done. Okay? This one says g of f of 1. So this one's going in, you're using the functions in a different order. You're supposed to find f of 1 first. So put 1 into f. So we came over here, put a 1 here, and we got 5. Now that's a coincidence that we got a 5 here and we got a 5 here. Okay, just a coincidence. But then that 5 is now supposed to get placed into function g. So we came up to function g, we put a 5 there, and we got 53 as an answer. And then C says f of -2. So put -2 into f, put that answer back into f, and we got negative 27 as an answer. Okay? You can also do these using charts. This is like it's kind of like a T-chart, a horizontal T-chart. These are your input values, and then these are the output values for function f of x and g of x. So there's no math to do. Okay, it's just f of g of 1. So put 1 into g. Well, when 1 is my input, I get 0 as an output. But then that 0 is supposed to get plugged into function f. So we go back to the top row, because that's our input row. There's 0. And when you put a 0 into function f, you get 5 as an answer. So that's what we did for all of these. There's really not a lot of work to show. You just follow, like example D, g of 1. So 1 is an input into function g, you get 0 as an output. But then that 0 is getting put right back into function g. So now 0 is in my input, and I get 1 as an output. And that's where these answers are coming from. All right, and then on the last page, so this is the third way that they show how to do composite functions. So what this is, it's just a graph. So that's just like a physical representation of the ordered pairs they did in the previous example. And you've got two graphs here. So this is the graph of f of x, looks like this, like an upside down V. And then you've got the graph of g of x. So all these points would be ordered pairs. This input gives you that output. This input for function f gives you that output. So that's what all these ordered pairs are. Don't ignore the fact that any x-intercept or y-intercept is also a point that you know. They just didn't highlight those. And then there could also be, I mean, there's an infinite amount of points right here, but there's just certain ones that they highlighted for us, okay? So if you look at like example 1, it says, what is f of g of 2? So again, this means put the number 2 into function g. Well, when 2 is an input into function g, you get 3 as an output. But then that 3, that answer 3, is going to get put into function f, okay? So here's 3, and this is function f, so this would be the point 3, 0. So when you put a 3 in f, you get 0 as an answer, okay? And that's what all of those are. Now, you can also create a composite function. So just like you can add two functions together and create a new function called f plus g, you can also create a composite function. So look at the first example. It says find f of g. So this literally means we are going to put function g, we're going to put this entire expression into function f where that x is. So that's what I did. I simplified, I distributed, I combined like terms, and this is a new function called f of g. So if I said to you, hey, what's f of g of 1? You could literally just, instead of doing what we did on the first page and putting a 1 into g and doing that math and putting that into f and doing that math, this function does it for us. So if you put a 1 right here, you would get 1 squared times 8 plus 13, which is 21. Well, if you look on the previous page, I'll just go ahead and flip. That's actually what I had you do on the very first one. We found f of g of 1. They were the exact same two functions, and we went through the process of doing it one at a time, and we got an answer of 21. Okay, so that's what this is. It's a composite function, and it does that for us. And then example B, I went the other direction. So it says, what is g of f? So we put function f into function g, and then we simplified it. Okay, now both of these have domains of all real numbers, but that's not always going to be the case. So here in this box, these are the rules. This is how you find the domain of a composite function. Okay, so first, find the composite function. So you're going to have to create that function. You're going to have to put, so in this case, it says f of g of x. So in this case, you would put function g inside of function f and simplify it. If it said g of f of x, then you'd go the other direction. So you got to pay attention to what it says. And then you're going to look at that function you just made, and you're going to find the domain. Okay, so it's going to, there's going to be, if there's a fraction, we're going to make sure the denominator doesn't equal 0. If there's a radical, we're going to check that. Okay, and then there's a third step. You've got to go back and look at the original function that got placed inside the other one. Okay, so in this case, it'd be function g, your starting function. you've also got to look at the domain of that. If there is a value that's going to make that function break down before you ever get a chance to put it into the other function, you have to exclude that as well. So I've got a couple examples here where that happens. So like the first example, I gave you these two functions and I said, what is f of g? So I put function g inside of function f and I got this. Now, this could be simplified. I went ahead and took the denominator and I combined like terms. Well, I had to get a common denominator between the 4x and the 4. So I rewrote that as 4x over x and then I added them together. But now I'm dividing by a fraction so I can multiply by that fraction's reciprocal. So this is my composite function. Then I looked at that. Now actually look down here. This is step 2. I flip-flopped those, so this is step 2. So I took this composite function and I set it not equal to 0, the denominator, and I solved and I figured out what x cannot equal. But that's not the only thing we need to exclude. If you go back and look at the original function g that got placed inside of function f, this has a restriction that x cannot equal 0. So that is another restriction. So both of these are restrictions. The obvious one that you can look at the composite and see, but also this extra restriction by looking at the original function that got placed inside the other one. Okay? For example, B, I went the other way. So this says g of f of x. And so here's me creating the composite function. So I put this function into this and then I was done. There's nothing else I could do. Then I found the domain of this composite function. I said, okay, x minus 1 is under a radical sign. So x minus 1, normally we would put greater than or equal to 0. But since this also happens to be in the denominator of a fraction, we need to get rid of the or equal 0 option. So we just put x minus 1 is greater than 0. We solved, we got x is greater than 1. Fine. Then I went back and looked at the original function that got placed inside the other one. So in this case, it was function f. That was our starting function. So I looked at the domain of that. And now this one is not in a fraction. So this one I just said x minus 1 is greater than or equal to 0. Done. I solved it and I got this. Now, these two answers kind of go against each other. This one says x is greater than 1 and this one says x is greater than or equal to 1. So there's a little discrepancy there. If you have a situation like this, then always go with the more strict option. So this one says that the number 1 is okay. This one says no, it's not. So you have to go with that one. That's going to be the domain whenever there's a conflict between your two answers. Okay? All right. So that is operations with composite functions. So take a look at your worksheet and let me know if you have questions. Thanks.